Mr. Bullock here, and this is on graphing parallel and perpendicular lines. It's a pretty good lesson, pretty easy to understand. So here we go. Let's graph, and this is part 2 of our integrated math series, part 2 of Unit 2, Section 4. So, all right, so let's graph the equation y equals 2x minus 3. Okay, we've done these already, so we're going to go to this minus 3 first on the y-axis. And since these numbers are reasonably small, I'm going to do these scales as a scale of 1. So there we go. So to save some spacing and stuff, and so they don't get too crowded, I did them by 2s and 4s. So this is 1, this is 2. Okay, so we went down to this minus 3 right here. Okay, so that minus 3 is on my y-axis. That's why it's called the y-intercept. Then we're going to use this slope right here. Okay, this slope is 2 over 1. That means I am going to go up 2 to the right 1. So here I did. I went up 1, 2, and then to the right 1, and I made another point right there. So there's that. I'm going to go ahead and connect those 2 points right there at the straight line. Notice I put the equation right next to the line. Okay, now on this same graph, you guys, I want us to graph y equals 2x plus 1 this time. Okay, so here we're going to go to this plus 1 first, so that's going to be right here on the y-axis. That's our y-intercept, y equals mx plus b. So there it is right there, to graph the plus 1, okay, and then again we're going to use the slope, up 2 to the right 1. So I'm going to go up 2 to the right 1 and put a point right there, okay. So connect those up, and then notice I wrote the equation of that line right there. Okay, these two lines are they're called parallel. So what did you notice about their graphs? Well, they're parallel to each other. Parallel means they will never intersect. Okay, and when we get into geometry, you guys, we have symbols that we put on the lines, and they're these red arrows. And if we put these red arrows on here, that's our symboling to let our eyes know that these lines are parallel, because there's a whole semester in geometry that deals with parallel lines. Actually, the whole year in geometry deals with parallel lines. So we always put red arrows there so we can physically see that these lines are parallel to each other, okay? So those red arrows show that they're parallel. So what did you notice about their equations? Okay, well, let's take a look at these equations. Y equals 2x plus 1, y equals 2x minus 3. Well, they have the same slope. The same slope as this red 2 right here. And if they have the same slope, that's why these lines are parallel, because you can just keep going up 2 over 3, up 2 over 3, and it's going to have the same slope. Okay, all right, now check this guy out here. Let's graph y equals 2/3 x minus 1. Okay, let's go to the minus 1. So my y-intercept is going to be right there. Again, that's going to be negative 1. So I'll put the scale in also right there. So I'll go down to negative 1 right there. I get emails from Twitter. I signed up for Twitter about 3 years ago, and I don't go on there, and I keep getting those emails. I just delete them. I don't even know what those are. Anyway, so I go up 2 to the right 3, up 2 to the right 3. So from here, up 2, 1, 2, and then to the right 3, 1, 2, 3. So I'm going to put a dot right there. Okay, so the slope is that 2/3 up 2 to the right 3. Connect them up. Notice I wrote the equation right next to the line right there. The reason why I didn't write it over here, you'll see why in just a second. So let's graph another line. Let's graph y equals negative 3/2 x plus 3, and I put the negative so we can see it a little bit better. I did that for my students in class right there. Okay, so first I'm going to do this y-intercept and do a plus 3 right there. Okay, these ones aren't going to be parallel. All right, so there's that plus 3 right there. That plus 3 is that, and then the slope is negative 3/2, so that means go down 3 to the right 2. So I'm going to go down 3. The slope is negative 3. 1, 2, 3, and then to the right 2, 1, 2. So that's what this red point is right here. I'm going to connect it up with that blue guy right there. Make sure you extend it so they intersect each other. Okay, those lines are definitely not parallel right there. And you remember back in, I think it was in 4th grade, you guys, they talked about right angles. Can you see that this is a right angle right there? Can you see that right there? That is a right angle. So right angles make these lines that are called, oops, I forgot to put the equation right there. So there it is. So these right angles, what did you notice about their graphs? They make right angles, And right angles make perpendicular lines. So these lines are perpendicular, and that's how you spell perpendicular. And to show perpendicular, we put this red little box right here. That's code word right there, right angle or perpendicular right there, okay? So in geometry, you'll see a lot of that symboling right there. All right. So I just moved it up a little bit. So what did you notice about their equations? Okay, well here's their equations right here, you guys. One has slope 2/3, and the other one has slope -3/2. Okay, so one has slope 2/3, and the other one has slope -3/2. So what we're going to say is this, you guys. Let's see. Oops, I know what I'm going to do. Lines that are parallel have equal slopes, you guys, and then lines that are perpendicular have to be opposite reciprocals of each other. Reciprocals, remember reciprocals means to just flip it. So this is a positive 2/3. This is a -3/2. Okay. So here is 2/3. Here's a -3/2. Do you see how one's positive, one's negative? Okay, so these guys are opposites. That's why I said opposites. And they're reciprocals of each other. And if they're opposite reciprocals, you guys, they're going to give us perpendicular lines. All right. I hope that makes sense, you guys. I hope you're having a great year, by the way. Take care.